Okay, good afternoon. I hope you hear my voice. Moi moi teacher, there someone wrote. Moi moi. Hyvää iltapäivää is good afternoon in Finnish. I will write it here. Hyvää means good. Ilta means evening and päivä means day. This iltapäivä means afternoon. Okay, we have had, or actually I will show something from the Moodle first. I put here in the Moodle there is this part of here mathematics refresher course in where I put always these videos and PDFs of this my notes during lessons, and I put there today. You may see these video recordings here, both in online course and both in campus course, so you may watch those if you like. Today I put some pages from this book I have shown you. Sorry, you can't see probably it. This which is a Finnish formula book of formulas, but you probably have own books, but I just scanned some pages from that book from the beginning, so that you may see the same formulas in the same form as I show you there. I will show them from my book, but you see these few pages from the first pages of this book. I would be glad to see what kind of book of formulas do you all have there, if you have in your home country some formula book, what you have used in your mathematics lessons. Please send a picture of those books to via WhatsApp or via email. And then I opened there. I'll show again this. Let's go to the first page there. There is also links to other Moodle courses. I opened them here. You may go there using this enrollment key. I have seen that someone of you have already visited there. They are unfortunately only in Finnish, and it is not necessary to actually study with the help of those Moodle pages. But if someone wants to get some kind of view of some mathematics courses I have in Finnish, so feel free to look at those pages. Those are in Finnish, but I guess many examples you may understand, even though you won't understand Finnish language. But probably it is a good to somehow listen to Finnish language, because it would help you to, if you would understand some basic Finnish concerning mathematics or some kind of technology areas. and here this matematiikan täydennyskurssi here, which is shown, it is almost same as this refresher course which we have in the beginning of this algebra and geometry course. And this rakennustekniikan algebra, it is in Finnish, it is somehow like, it means algebra for civil engineering students. I mostly teach for civil engineering students, so my material there is concentrated of their area. So it is a bit different than for example in automation engineering. But as I said, if you have time and want to watch something from other courses, it's okay. Probably I will put some other module courses there also, when I have time. It is my pleasure if you like to visit in those courses and listen to my Finnish videos. But then let's continue on this basic calculation test, and we have had the 3 times 5 is 15. We have gone through 15 problems, and now we will take those last 5 of those calculation rule test. And the next one is problem 12. Kaksitoista in Finnish. Kaksi is 2, and toista means second. So it's like 2 of the second, or 2 from the second. 2 from of the second 10. Actually this means in Finnish. 12. 12. And the problem is this kind of problem. Quite easy if you know what to do. Simplify this kind of expression. So there is sum inside the brackets, and there is exponent 3. And we sorry, it was not like that. A plus 2 raised to the power of 3. And in this point, there are I think couple of ways to solve this. You may notice that there is exponent 3 there. So it means there is multiplication with these brackets 3 times. So this is actually same as this. And you may calculate this by first multiplying these two with each other, and then you will get some answer from this, and then after that you will multiply this answer with this. It's quite a long procedure, and I won't do it right now. Actually, it is not so nice work, but I will use a simple formula which is shown in this, for example, in this formula book, and I guess in every mathematical formula books it is shown. And it is in this book, it is on the page 8. I have scanned this page to the Moodle material, so you will find this same page there, page 8, and there we have polynomien kertoja, jaollisuus ja sääntöjä. It is if I translate it in English, it means multiplication and division rules for polynomials. That is that sentence in English. And here we have this formula here, a plus or minus b inside brackets and exponent 3. And then we have this way how to open that. I will write that formula. Oh, it doesn't show very good. I'll take another color. Let's take blue one. And in this formula book, it was written in this way. Actually, there is two formulas in this line or this row. I will write first as it is written in this book. A plus minus b cubic or raised to the power of 3 equals a cubic plus minus 3a squared b plus 3ab squared plus minus b squared. Oh, sorry, b cubic, b raised to the power of 3. And in this point we have sum inside brackets or parentheses. So in this left hand side of this formula we have plus sign, the top sign in here. So we will use the top signs in this formula. Or every time we have two signs here, we take the top one. So if we have plus inside the brackets, then we will use those top signs here. So that means that we will use only plus signs. There won't come any minus signs if we have plus sign in this expression. So now we have this kind of situation, and we will take only the top signs. So it will be only plus signs. Many formula books have two formulas, so there is another formula for a case where there is minus sign here. So it will be this formula so that we will take the bottom sign. So it won't be all minuses, it will be minus plus minus. So here is minus. This is always plus, even though there is minus inside the brackets. But this is when we have minus here, so here we will take minus also. And this is actually a very easy problem when we have this 2 here. We have same letter A, so it won't change. It is all in the formula also there is A letter. This is a coincidence. But here we have B and here we have 2. So actually it means that we will use this formula so that we will only put 2 in the place of B. A plus 2 cubic equals a to the power of 3 plus 3 times a squared times, and now we have here this b, which equals 2 in this case. So we will get 2. Let's write that it means b. And then we have 3a, and then we have this b squared, and now we had 2 in the place of b, so it will be 2 squared. So this is b squared. And the last one we have plus b cubic, so b raised to the power of 3, and we have 2 in the place of b, so it will be 2 cubic. This is same as b cubic, b raised to the power of 3. And now we don't have so much to do anymore. Only we make these multiplications, and maybe if there are power expressions, we will calculate this exponent, what they will be. A cubic stays, and then we have 3 times 2, it equals 6, a squared, and then we have here 3 times 2 squared. 2 squared is the same as 4. 3 times 4 equals 12. So it will be 12, and here a. And the last one, 2 raised to the power of 3. 2 times 2 times 2 equals 8. So this is the final answer in this problem. This formula is a formula which is, as I said, it's usually shown in every mathematical formula books, but it is quite easy to remember also. If we watch this formula, I will write it again here. I'll change the color. How I do remember that, how it is for me, it is quite easy to remember. For example, if we have this a plus 3 cubic, I will first watch the triangle shown in this same page in this formula book. Here it is in Finnish Pascalin kolmio, Pascal triangle. Kolmio is the same as triangle. And here we see a plus b cubic, and there will be numbers 1, 3, 3, 1. I remember those numbers 1, 3, 3, 1. So I would write it like this: 1, 3, 3, 1. I leave space here, and then I will watch that there is plus sign there, so there will be plus signs in front of these numbers. And then we have first letter in this formula, it is A. So I will write A's behind after those numbers. And the exponent or power in this sentence is 3. I will start with 3. I will write 3 here, and then I will go to the downstairs. Here is 3 exponent, and here is 2, here is 1, and here is 0. And then we have B letter in this formula in the left hand side, and the exponent is 3. And I will do the same with B as I did with A, but I will start in this side. So we have B and exponent 3. Here we have B and exponent 2, B and exponent 1, and B and exponent 0. So if we watch those exponents, there will be, oh sorry, is there someone coming here? I can't see if there is. I think it's okay. And then we have, if we watch these exponents, the sum of exponents are always the same number as here. So here are 3 plus 0, 2 plus 1, 1 plus 2, 0 plus 3. So actually I could write this so that if I first write a with exponent, then I will give b exponent, which is 3 minus this exponent of a, so it stays 0. So I will give exponent so that their sum is always 3, the same as the exponent here, or power in here. So if I write here 2, here must be 1. If I give a 1, so b must get 2. And if I give 0 for a, b must get 3. This way to write this formula is not actually so helpful if we have quite simple or low exponent as 3. But the same method works when we have, for example, exponent 4 or 5 or 6 or etc. So the same rule holds. And now when I have written this this expression like this, I will see that there are these 0 exponents, for example here b to the exponent of 0, and this equals 1. As we see from this formula book, we had this formula here that when which shows that when we have something raised to the power of 0, it is always 1. So here this b raised to the power of 0, it equals 1, and same happens here. This equals also 1. And of course these factors which are 1 we can eliminate there. It is not necessary to write. And exponents 1 we don't have to write them. So this will be a cubic plus 3a squared b plus 3ab squared plus b cubic. This is the same as the formula in that book. Sometimes this formula is quite useful, not necessarily only in algebra, almost also in statistics or probability. This is useful formula. So 12 will be like that. And then we will take well, actually I forgot to write. This problem was correct in 67% of tests I was sent it. It means 2 of the 3 students could calculate this correctly. And then I will take the problem 11. Yksitoista. So there is some same logic there. 12, 2 of the second 10, and 11, 1 of the second 10. And this was problem which was correct only in 41% of tests. And it is this kind of expression. Simplify that expression actually quite nasty. 3a plus b squared minus a plus b plus 4 minus, and then we have to be careful. There are two brackets there, or two parentheses there. I will write them, these outer parentheses, a little bit bigger. So this will be the bigger bracket. Actually, this was only an exercise in which it was needed this formula we used earlier. It was in the same page as this cubic formula. It's like here, actually, also with the same letters, so we get the right answer from there immediately. But I think this was quite easy for many of students who made this, but they made some small mistakes. I remember that in this problem there were many final results which were almost correct. There maybe was some factor or some coefficient wrongly. Probably there was some kind of mistakes, for example 3 minus 1, so it should be 2, and student had calculated it 4. Very simple error, but still it resulted to a wrong answer, final answer. Let's open these last brackets here. There is minus sign in front of these brackets, so it will change the signs of this sum expression here. These are not inside the bracket. I will write them exactly the same as they are in the beginning. And now I get this minus sign here, and that means that all these will change signs. I have here this expression, and it will be this plus here, but minus changes it to minus. And then I have this minus 2 here, and this minus changes it to plus 2. And then we have still this plus 3, which will be minus 3. And then we have an expression where there are a plus b squared in two places, here and here. So we may combine these parts here. And then we have a plus b 2 times here. So they can also be combined. I will, what kind of marks, I will put this kind of line here. And then we have these numbers, simple numbers, 4 and minus 3 there. I won't put any line there, so these which are left are combined together. So we have 3a plus b squared and minus a plus b squared. So 3 minus 1 equals 2, so we will get 2a plus b squared. And then we have a plus b, here we have 2 and minus, so this means minus 1. 2 minus 1 equals 1. I will write this 1 here, so I will show that I have, sorry, there are no exponent here. 1 a plus b. and then we have 4 minus 3, it equals 1 plus 1. Now some left the answer in this point, and I think it is some kind of opinion case. Probably I gave only half points for persons who or students who left the expression in this form. Actually, I should have written the problem so that if it is read here, I wrote that simplify the expression. That leaves the opinion way to handle this. I should have written this simplify and eliminate the brackets. So that would be a correct way to express the problem. But if we take those brackets away, so here we have this algebra memory formula here, a plus b squared, which we had, I think, yesterday or day before yesterday. So we will use this. We have 2, and then we get a squared plus 2ab plus b squared. And then 1 times these brackets, nothing changed, so it is only a plus b plus 1. And then after this, we will multiply with this 2 and open these first parentheses or brackets. But as I said, this is some kind of opinion, or only that which one is the most simplest expression. So the last version would be this. That was problem 11. And then we have finally this problem 19, which was asked a long time ago to be solved. Problem 19. Tehtävä 19. Tehtävä 19. 19. This means 19. Again, 9 is the same as 9. This number here is 9, and 19 is 9 of the second 10. And what was the problem? It was equation 9x divided by 4 minus 2x minus 5 divided by 3 equals 2 plus x. I think most common error in this problem was this minus sign. This is dangerous here. You have to be very careful if you have minus sign in between these fractions. This was correct in 61 papers. 61% of papers. And now, if we compare this problem, for example, this 18 and 20, there are some similarities there. Both have two fractions. Here are two fractions and here are two fractions, and also in this 19 there are two fractions. But the problem is that those fractions are not in different sides of equations, and also there are something which is not in fraction format. So I would do, there are many ways to solve this problem, but I would do so that I would expand these fractions so that I will get the same number to the bottom part. So I will expand this with 3 and this with 4. As I said, there are other ways also, but I think this may be a good way. So after this I will have, if I expand with 3, I will multiply with 3 both top and bottom parts. So here I will get 27x divided by 12 minus, and then I have here, I will multiply with 4. So all these numbers will be multiplied with 4. So I get 8x minus 20 divided by 12 equals 2 plus x. I would also do one thing. Here I get 12 to the bottom part of these fractions. It would be helpful if I would expand also this expression here is 2 plus x, expand also with 12. So I will also get 12 to the bottom part of this right hand side. It is possible, and I think many likes to solve it like that. But I can also do that so that I will combine these. I have both have the same bottom part, so I will combine this left hand side so that I get 12 to the bottom part. And then important thing, I will combine these top parts there. This is easy. The first one, 27x minus, and then I have to be careful. This all mostly goes right, but most common error is that student writes minus 20 here. And I think this was a reason for most wrong answers in this problem, even though student actually knew what to do when was solving this problem. But here I wrote a sign error there because this minus signs changes the signs also changes the sign of 8 and also the sign of minus 20. So this sign here should be plus sign. So I will write there with the red color if I find the red pen. Here I hope. Note the sign change. And then the right hand side stays 2 plus x. If you did not get points from this problem, check that if you made a mistake here. And then I will get here 27 minus 8 equals 19x plus 20 divided by 12 equals 2 plus x. After this, I already have a quite simple equation. Maybe I would do so that I will multiply this equation by 12. Sorry about those colors. This is much more red, this color, than it is shown in the paper. And when I multiply with 12, it means that this left hand side is multiplied by 12, so this 12 in the bottom part will be cancelled, so it there only stays 19x plus 20. And then in the right hand side, both of these are multiplied by 12, so it will be 24 plus 12x. And at this point we have the same format or form than we had in this most simple equation 17. So I will solve that with the same way. I will move this 12 to the left hand side and 20 to the right hand side. And so I will get 19x minus 12x. This sign changes, and then 24 stays in the right hand side, but 20 moves there, so it will be minus 20. 7x equals 4, and the final answer will be, when we divide by 7, x equals 4 divided by 7. So in this equation, the most I think it is quite easy. This expanding is quite easy process. When you see these easy numbers there in the bottom part, you just find numbers which will get the same bottom part. So we can combine these two fractions, but then this minus signs is dangerous there, so you have to remember to change the sign of the this easily you remember to do. You change the sign of 8, this first expression here, but this minus 20 should also change the sign. And after that it usually goes correct, but this is thing where you have to be a place where you have to be very careful. Please, if you have you still have, of course, you have those your test papers which you send or they took photos or send PDFs to me. Check those your calculations and try to find where did you make mistake, and if you don't find any mistake, please send me a question concerning that problem. Someone has already asked what was wrong in their problem, but compare those with my calculation, and if you can't find what is wrong, so just ask. We have next one is number 7. This was actually in this calculation rule test, tehtävä 7, problem 7. 7. This is 7. 7. This was actually problem which got lowest percentages in the skills test. 40, only 40% could calculate this correctly. I I'm afraid that it is nasty problem if I remember correctly. No, not so nasty. Oh, thankfully I have solved already that nastiest one. 7. Simplify this kind of expression. There is some kind of fraction there. There are two expressions divided by each other. And we should simplify that expression. I think quite many could do this correctly, but I think a quite common error or mistake was that somehow this 4 was forgotten in the problem. So there are 2 times 4, should be 8, and I don't know why there was many papers where there was written only 2. Maybe it was only forgotten to take that number there. 2, and then I will show you that easier to copy if you write notes. So actually, the easiest one first, 2 times 4 equals 8. I will write this like this expression like this. I will take 2 times 4, it is 8. And then I notice that there are bases which are all M letter. M, and it has some kind of exponent or power, and also here M is a base number and base M and base M. So all have the same base M. And then I will check the formula book, and also in the Moodle you have the same page there. This is the page 7, and we have here these potenssikaavoja, power rules or power formulas. And here we have the 2 formulas I will use. If we have the same base, here it is letter A, but in the problem we have letter M. If we have the same base and we multiply, then we add these exponents or these powers. But if we have division, the same base, different, or they may be also same exponents or same powers, but if we divide them, then we have to subtract these or minus those exponents or those powers. So I will combine these rules. So here I see that there are both multiplications and then there are also division there. So I will write this so that I will add these exponents or powers in the top part, and then I will minus or subtract the exponents or these powers from the bottom part. So actually I will do so that I will write these exponents first exactly the same, minus 2 plus 3n, and then I have 1, and I will add these, so I will put plus sign here. 1 plus 8n, and then these exponents or these numbers here in the bottom part I will take here after this first part, but I will change the signs. That is exactly what this rule here says, that if I have exponent in the bottom part, I will change the sign of that exponent. So here I have minus, plus, plus, minus, and I will turn them to plus, minus, minus, plus. So here I will get plus 1 minus 7n minus 10 plus 2n. This is not the only way to solve this problem, but I somehow like this way. It is some kind of mechanical way to solve this. I only have to check that there are only the same base m here, and so I will put it once here, and then I only put these exponent parts there to the area, and then I will get the answer when I simplify this expression here. I have here n parts here. Here I have 3n, 8n, minus 7n, and 2n. And the other, those which are left, they are simple numbers there. So I will add first those n parts there. 8 and base is m, and then I have in this power or exponent 3 plus 8 equals 11 minus 7 equals 4 plus 2 equals 6. So it will be 6n. And then these simple numbers here, minus 2 plus 1 equals minus 1, plus 1 equals 0, and then there will be only minus 10. If you saw I'm making mistakes, please tell me. I guess this went right, but I may be uncareful also. Yes, and this is the final step in this problem. So actually this is also quite easy if you make this like in this mechanical way. So I think this is quite easy way to solve this. And then the last one of these calculation rules, number 13. Tehtävä or problem 13. 13. And this was one of the lowest percentages, 43%. So nearly half of the students could solve this. What kind of a problem was that? Oh no. 13. Simplify this kind of expression. Well, it is not hard at all. We have these fraction parts there, and we have inside the brackets, and then we have exponents there. We can use here, for example, this rule, which is shown also in this page 7 of this book. We have here division and then power, and this rule says that this exponent which this whole bracket gets, it will be exponent for both parts. So a per b, or a divided by b to the power of r equals a to the power of r divided by b to the power of r, and that can be used in this problem here. We have same kind of a situation there. So 3a's power is 5, and b squared times. Maybe the hardest one in this problem is to write this first expression correctly. If you write that wrong or make some mistakes, then it will be error in the answer. And now actually I saw this formula there, but also I will use this. We have a multiplication inside brackets, and we have exponent outside of brackets, and this exponent will come to the both of parts here. So A and B will both get the power of R. And I will combine both of those rules here. I will do so that I will write here a long division line and write those top parts in the top part and bottom parts into the bottom part. And this first sentence here, or first part here, it belongs to the top part. So there is 3a power of 5 and b squared. And then I start taking away these brackets here, and remember that this 3 or this exponent outside of this bracket will become an exponent for all of these here. So I will get x cubic, y cubic, they will come in the top part, and these AB which are in the bottom part will come here in the bottom part here. So A and B will get exponent 3. A cubic, B cubic. And here also the same thing. We have AB divided by 2xy, and all of those will get exponent 2. So we will get A squared, B squared, 2 squared, x squared, y squared. Squared. And after that, I'll check the numbers there. I got only number 3 there, and in the bottom part there is 2 squared, which is equal as 4. So I will get 3 divided by 4. I will write it in the beginning. And then I will find the bases. There are 4 different bases. There are A and B and X and Y. And I will do so that I will write mechanically A and B and X and Y. I will leave space between those letters, so I will have space to write the exponent there. So there are only 4 letters there. Only, or is it only? But 4 there are. A, B, X, Y. And then the exponents. In the top part of exponent, top part of this division, there are 5. For A, the exponent is 5 and 2. So I will plus those or add those together. And in the bottom part, we have A cubic, or A to the power of 3. And it is in the bottom part, so I will minus it, so subtract it. So here. So exponents in the top part, I will add them, and for exponent in the bottom part, I will subtract them. The same holds with B. In bottom part, top part, I have 2 plus 2, and in bottom part, I have minus 3. Or there is plus 3, but I will minus it because it is in the bottom part. And then X, I have here 3x and then in the bottom part 2 or -2 if I write here. And I guess the same holds in y. There are in the top part there is 3 and in the bottom part there is 2, so I will subtract it. So it is almost ready, so I only have to calculate those exponents correctly. I have a, and the exponent or power is 7 minus 3, it is 4. Then I have b, and there is exponent 4 minus 3, it equals 1. I will put the exponent 1 there, so it is not necessary, but I will put that. You don't think that I have forgotten to write something there. And also x and y, they will all both get exponent 1. So I have x exponent 1 and y exponent 1. This could be the final result of the problem. Of course, I could take those exponent 1, those powers of 1 away, so maybe the simplest way to write this is just to write those letters without exponents there. 3 divided by 4 times a to the power of 4 and times b times x times y. This could also be written, if you like, someone likes to use this division mark. Oh, sorry, it's not so. It is also possible to write this like this. Actually, I don't like this way to. I like to write this fraction part here in front of the sentence. So I'd prefer this form, but it is okay to write it also like this. So that was the last one of these basic calculation rules today. I think I will now do such thing that I will open in the Moodle problems concerning these last 5 problems, so you may practice that. Let's find out how to do that, or have I opened it already? No, I will open it. So there is training series 7. Which you could, which is for you to practice this. But before I let you to start practicing, I think I will take some kind of Finnish course here, if you know any Finnish words, so Finnish numbers. So do you remember? You may write to the chat box there, or also you may say it loudly. I again have this problem with my headphones. I don't know, understand why I can't hear from these headphones anything. I have to take them away. So we have Finnish numbers, and what is number 1 in Finnish? I will go to those triangle problems tomorrow I guess we have lessons. I'm not going to. Yes, yksi is the number one in Finnish. Yes, yksi. If you have microphones, you could open those and try to repeat that number. Yksi. Yksi. I know in some languages this y letter is quite. I think many language groups are such that they don't have this y letter. They sometimes it's hard to pronounce. Y. And number two, it's kaksi. Kaksi. Yes, exactly. Kaksi. Yksi, kaksi. Many times if someone is testing microphones or this how loud is heard, you may repeat yksi, kaksi, yksi, kaksi.
Yksi, kaksi.
Yksi, kaksi. How about number three?
Kolme.
Kolme. Yes. Kolme. Kolme. And then four.
Neljä.
Neljä. Neljä. Very nice Finnish. I love to hear you speaking Finnish. When you will come to Seinäjoki, I want you all try to teach me numbers in your own languages. I know that there are many languages you are speaking, and I'm very interested. Try to learn even at least something, but I know it is very hard for me. Then we have five.
Viisi. Viisi.
Viisi. Viisi. Number six.
Kuusi. Kuusi.
Kuusi. Yes. Kuusi. And this was, I guess I wrote that or draw that spruce tree. It is the same word. I think in many languages there are words that are written in the same way, but they mean different things. How about this? Seven.
Seitsemän.
Seitsemän. Seitsemän.
Kahdeksan.
Kahdeksan. Kahdeksan. Kahdeksan. Actually, in spoken Finnish, many times, for example, if I would say these numbers, probably I wouldn't say yksi, kaksi. I would say yksi, kaksi, kolme, or in my accent I would say kolme. I use this O letter between after this L or between this L and M letters, kolme, and also it is written neljä, but I would say it neljä. And viisi, you would say viisi or only viis. Kuusi or kuus. Seitsemän, in my dialect, I had to say, I probably used the wrong word, dialect. In my dialect, I would say seitsemän, kahdeksan, and I would say it kahdeksan without the. Actually, most Finns don't use these D letters. You in spoken Finnish, many, especially here in Seinäjoki area, they mostly don't pronounce this D letter. They use R letter there. So many in this area, this part of Finland say this kahdeksan, very hardly, or hard pronouncing, or tough pronouncing, kahdeksan. I don't speak actually the same dialect than they are speaking here in Seinäjoki area. So my dialect is more from the eastern part of Finland. So it is more near the Karelian dialect, which is spoken in eastern part of Finland. And then we have 9.
Oh, that's fine.
9, yes. It is somehow, I don't know if the etymology is this kind of, but somehow it is easier to remember these 8 and 9. They sound quite similar or seem quite similar. If you think that there are number, let's take this number 10 soon, but not yet. If you think the number 10, so this 9 is 1 below the number 10. 1 and 1 is yksi, and there we have 9. And this number 8 is 2 below the number 10, and here we have 8, 2. And someone has said that this actually comes from that way of thinking, but I'm not sure if that's correct way to think. But there seems to be something to do with number 1 and number 2. How about this number? 10. Yes, 10. And how about 11?
11.
Yes, these are very simple. If you remember these first numbers, it is easy to say the numbers from 11 to 11 to 19, because they have the same format. 11. You only put this toista word. 11, 12, 13. Try to repeat these numbers. 11,
11.
12,
12.
13.
13.
I will put it there. 14.
14.
15.
15.
16.
16.
17.
17.
18.
18.
19.
19.
Yes, and then we have, do you remember what is this? This has not the same logic. It is, well, there is 2, so there is 2.
It's 20.
Yeah, 20. Yes, but the logic is as you said, 20. We have, this means that we have 2 of tens, so it's 20. How about this number?
100.
100, yes. 100. 100. Uh, 1000. 1000.
Yes.
1000. By the way, this word toista here, you could translate it as I said, 1 of the second 10. This means something like 10 second. But toista in Finnish also means repeat. repeat. It is toista. It is toinen is the second. Toinen. This is that's if you mean sorry, I would like second, so there is no misunderstanding. The word second in clock time in time, yes, in time it is sekunti. Sekunti. Tunti, hour. We also say, for example, in school, when we have lesson, we say it oppitunti. Oppi is like some kind of learning, or how do you translate it? It means something like learning, and tunti is hour. Oppitunti is learning hour, or something like that, if you translate it like from word to word. Okay, is there any Finnish words? Mostly, or they could be mathematical words, or some other words. If you would like to learn, I will gladly tell you what kind of words they are. Just tell if there are. I'm not sure if you have.
What about shapes, names, like
Square.
circle? Yes.
Yeah. For example, if we have this kind of drawing, this is square. It is in Finland neliö. Neliö, you may see the word neljä, and it comes from, there are four sides there, so it is neliö. And the same word, if we have, for example, we 5 squared, we could say it, we have this number 5 there, and we could say it viiden neliö, the square of 5, or mostly we say it 5 potenssiin 2, 5 to the power of 2. I guess we probably had this already, but triangle. Triangle. It has same actually in English words and in many other languages also. There in the name there is the number 3, triangle, 3 angle. And in Finnish also there you may see the number 3 there, 3, so it is kolmio. Triangle. Circle. In Finnish it is ympyrä. I guess from this word comes the Finnish word for to understand. To understand. It is ymmärtää. I think originally it comes from the word circle in Finnish language. I'm not actually understand the logic in there, but there are something when you understand something, maybe you close the circle, or I don't know if they have thought it like that. No, of course, line. In Finnish it is suora. Suora. Suora means in Finnish, how do you say it? So it is not. It doesn't go. I don't know the words in English, but it doesn't go like this, but it goes straight. So yeah,
Straight line.
Yeah, straight line. So that is suora in Finnish. You give someone don't know where to go, and you say that menet suoraan. You go straight forward. So the word suora is there also. Of course, and not square, but this kind of form, rectangle. There also is the same situation that there are four sides there, and it is shown in the Finnish word. This square where the sides were the same size, it was neliö, but this is, there are actually two words which could be used, either nelikulmio, actually this is not really correct. Nelikulmio means only some kind of figure in which there are four angles. So it is not. This is wrong. This is not nelikulmio. This is, of course, this is also nelikulmio, but the right word for rectangle is in Finnish. It is suora kulmio. Suora kulmio actually is quite same as this rectangle in English. Rectangle means that there are right angles in this figure. Here there are four right angles there. So this means that there are right angles, and in Finnish this means the same. There are suora kulma means the right angle, and this is a figure which has right angles. It is suora kulmio. It could be also said it is suora kaide. Both means the same. Actually, I don't understand why there is this kaide word, but these mean the same thing. Yes. Yes. Well, if there comes up to mind some words you would like to know for Finnish language, just tell me. But I think I'm not today going anymore. There's enough to try to remember right now. But again, when you come to Finland, or even before that, I'm very glad if you sometimes would give me your expressions in your own language, how to say neljä or square or like that. I'm planning to do some kind of dictionary for students in my international courses. So there would be words in for example Hindi language or Farsi language or Bengal language or whatever languages there are, and also Finnish language. So that is quite a big project, but I will start it this autumn, and I would like to get help. So maybe sometimes when if I will be lecturing these courses next year, so it will help my future students to more easily to get to understand Finnish language and other languages also, if you have and when you have students from many different language areas. Yes, but today I won't. Yes, thank you. Somebody has already left the teams, but I will stay here still up to 16 or 15 minutes still, but I give you time to practice your exercises there, and if you have something to ask, just ask. But I will end my lesson actually, or my recording will end right now. Yes, thank you. Well, actually, many have asked these homeworks. Not yet. These exercises I am giving there, they are not that kind of homework that you should have to return to me or send to me. But there will be time during this autumn when I will exactly tell that what you have to calculate at your home or in school and send to me to check, and but it is not yet that time.